Hello Gen Chem friends, I hope you're doing well today. So we are now finally at the point where we can start to do some practice problems that specifically speak to the title of this chapter, mainly stoichiometry. We're going to start by doing stoichiometry of compounds. Specifically, we're going to use the chemical formula for a compound and the subscripts of that chemical formula to relate moles of that compound to moles of the individual atoms that make up that substance. So for example, if I had this hydrocarbon C2H6, you know from chapter 2 that one molecule of C2H6 is going to have 2 carbons and 6 hydrogen atoms. I can take that ratio on a molecule, single molecule level, and put it on a mole level. So if I had a whole mole of that hydrocarbon of C2H6, then I'm going to have twice as many moles of carbon, because I've got, for every 2 carbons, I have 1 molecule. I'm going to have twice as many moles of carbon and 6 times as many moles of hydrogen. So those conversion factors, or those subscripts that we can use as conversion factors on a mole basis, is going to be really important and useful to us going forward in this chapter. So to determine those conversion factors for the molecule, you just use the subscripts of the balanced chemical formula to relate moles of that particular atom to 1 mole of the entire compound. So for example, if I asked you what the conversion factors for each atom were in ammonium phosphate, you would use those subscripts, making sure that you remember that the 3 that is out here with the ammonium, the 3 goes into everything. Let me get my pointer here. The 3 goes into everything. So that means I have, for every 1 mole of ammonium nitrate, I have 3 moles of nitrogen and 4 times 3, or 12 moles of hydrogen. 1 mole of phosphorus and 4 moles of oxygen. So from those subscripts in the balanced chemical formula, where we can relate moles of atom to moles of the entire compound, hey, we can use those conversion factors to do more stoichiometry. So if I gave you this amount, 1.7 moles of calcium carbonate, and asked for the number of moles of oxygen, you would look at this and say, oh, the relationship between moles of the entire compound and moles of oxygen is a 1-to-3 relationship, which I get from the subscripts in the balanced chemical formula. And so you do that problem just like you would any other conversion problem. Write down number and unit that you're given. Leave yourself space to work the problem. Write down number and unit that you're looking for. Write your conversion factor appropriately so your units cancel. Do the appropriate multiplication, and you're left with moles of oxygen. So we can kick it up a notch. What if I was to ask you how many grams of oxygen that would be? Well, I already know how many moles of oxygen I have. How could I go from moles of oxygen to grams of oxygen? Going from moles of oxygen to grams of oxygen? That means I'm going to use the molar mass of oxygen from the periodic table. So for every 1 mole of O, I look at my periodic table and I have 16.00 grams of O. And so you do that mathematics. So 16 times 5.1 should give you 81.6, or if I was being picky with sig figs, that would give you 82 grams. So that's how we can use how we can use subscripts in a balanced chemical formula to say something about the elemental composition of a molecule. So this process that we just talked about, and we're going to do some more examples in the next video, makes use of using coefficients from the balanced chemical formula, always from moles of substance to moles of what you're looking for. And so in this problem, we were given moles of some substance. We were given moles of A. I needed to find moles of B, or moles of oxygen, and then grams of oxygen. And I did that by going from moles of calcium carbonate to moles of oxygen, using those coefficients of the formula. Moles of oxygen to grams, using that substance's molar mass. So in the next video, we're going to do some more problems using this flowchart. But instead of starting with moles of a substance, I'm going to give you grams of substance. The only other step we will need to add is going to a chemist's favorite unit, the mole, by using that substance's molar mass.